Yeah, you're welcome. Okay. Okay. Time planner implement a function. Uh, Meeting time planner. Working both of them on its duration. If there is no common time slot that during a positive integration and present the duration of meeting second.
Um, yeah, so if you have any difficulty understanding the question, please let me know. I can
Yeah. Can you give me a hint
Sure.
about this question?
So I'll just explain what the problem is talking about. So you are about to create a meeting
Okay.
planner, okay? So it's
Okay. Oh, yes.
to imagine that two people want to have a chat, and
Mm-hmm.
so both. So what the inputs that you are given is the duration for which they want to talk, okay, and
Mm-hmm.
the availability slot A shows the availability of person A, slot B shows the
Mm-hmm.
availability of person B. So the every ith value in slot A or slot B shows the start time and end time. Let's say you have a clock with you, so you are free from 9 to 10 or 11 to 12 or so and so
Mm-hmm.
forth. Like throughout the day, what time you are free, those the slots are showing that. Okay,
Yeah.
and
Okay.
you need to figure out if both of them can have a meeting in the given time slots they have today. If not, so basically that's what you do, right? If you want to set a meeting with someone, you see their calendar, and if they have slots available, then you can have meeting on that day. Otherwise you will have meeting on the next day. So let's say
Mm-hmm.
if you cannot have meeting on the given day, so this is the Yeah, so you can just return a empty array. So as shown in the example 2, you can see since there is
Yeah.
no common slots whose duration is 12, so you basically send an empty, and if you find a slot where they can have a meeting, you can just send what slot they can have meeting at. So it's basically that. Hopefully my explanation was clear, and if not, then let me know. I can explain you the question.
Okay, okay. Sorry, we have an input for uh, person first person. Yeah,
Yeah,
this is the time availability for first person, and this is the for second person.
yeah, slot A for first person, slot B for second person. Yes.
Yeah, yeah, and the duration they must meet during just 8 minutes, for example. Yes.
Yeah, they are looking for a 8 minute meeting. Yes, in the
Okay,
example.
and this is yeah in the example, and this is the output uh, from this entire input. Yes.
Yeah, yeah.
Yeah. For this input, I should find this. Okay, 60 and 68. This is the slot. Okay. Sorry, sorry. I didn't understand it. I did not understand it.
You didn't understand the. Sorry, my bad.
I
Sorry,
cannot hear you. I
sorry,
cannot
I
hear
was on
you.
mute. Yeah. So you didn't understand the question, or
I understand the question, but
like,
this is the availability time of array for first person, and this is for the second person, and the question asking that which available time for both of them is matching. Yeah,
yeah,
is yeah. We should find uh, appropriate or good time that meet all numbers in this area and this area, in both of these areas.
yeah, yeah, yeah. So, walk me through what you're thinking, like
Okay.
in terms of solution, or if you need time, then yeah, you can take your time. But what is the first approach that is coming to your mind when you see this problem, like after understanding the problem?
Okay. Let me uh, showing the second. Yeah, this is the slot A, and this is the slot B.
So you understand, right? What is in slot ith element, like 10 and 50? What is that representing?
Let me read again. Just okay. Implement the function meeting planner that gives the availability to people and meeting duration. Return the earliest time slot that work for both of them. It's a duration. Oh, if there is no common times. Empty. Okay. Yeah, yeah. I understand the question. Okay, this is the nearest availability time should be for both of them. Okay.
Mm-hmm.
Okay. Can you? This is a one, and this is a let. First of all, we create an empty for meeting time for both of them. Okay.
Mm-hmm.
And then we have to check the array. Okay. This is the array. Mm,
So how are
slot
you
view.
planning? Like, if you want to code it out and explain what's your thought process, then it's totally up to you. Or you can let me know.
Oh,
And if you need some
oh,
nudge in some direction, let me know. I can help you out.
okay. Can you first of all give me a small example? For example, from slot A and slot B, and the output for this
So yeah, I can
two
I can
slot. Okay.
totally do that. Okay, cool.
Okay.
So see, what the question is saying that the time slots that have been given, they are not overlapping, meaning there won't be a
Yeah.
conflict for person A's time, like whatever time slots he has. There is no overlap in that. And person
Yeah.
similarly, it goes to person B. Okay, so um, I'll just walk you through the example that they have given us. So
Okay.
consider the first example. They want to talk for duration 8 and the slots are given, right? So what
Yeah.
if you see for slot, we'll compare the 0th index of slot A and slot B. Uh,
Yeah.
we'll see that can they have the meeting there. Okay, so person A looks like person A is available from 10 and
Yeah.
person B is available from 0. Okay, so
Yeah.
meeting can start from 10, right? Meeting can start from 10. Is that right?
Yeah.
For both of them, meeting
Yeah.
will
Yeah.
start
Yeah.
at 10. But
Yeah.
again, we have to check if the meeting can go for 8-minute duration. So what will you do? You have to see the time slot that they are available on the 0th index if the meeting can be conducted in that duration. So you'll see
Yeah.
if I add 8 minutes to the first meeting, like the first slot, will there be a
Yeah.
meeting there? So slot B, um, I guess it is not possible there because it is exceeding if we start the meeting at 10. So you remember, right? We have to take whichever, like the maximum of it, and then from that point the meeting will start. So once we
Yeah.
add the duration to it, it is exceeding person B's time of the availability. So it's obvious that we cannot do the meeting there. So eventually, when we traverse the array, we get at 60 and 70. So in this time slot, if we add if we add 8, like we can see, uh, are we getting the 8-minute time duration in these time slots? So yes, we are getting the 8-minute time duration. So we can clearly say that we can start the meeting at 60, both are available there, and then we can say that 868, yeah, 60 plus 8 is 68. So the meeting can be conducted in this time frame, both are available, so it's a win-win situation, and we
Mhm.
send back the answer. Hopefully
Yeah.
this was a good hint for you to proceed. If not, then let me know. I can give
Yeah,
you
yeah.
another hint. You know.
Okay. uh, Sorry, we have you know in the this array of two numbers here. For example, this is the hour and this is the minute. Yeah.
This is, yeah, the time slot, 60 and 20, 120 you are saying? Uh,
For example, this one is 10
like I'm not
and
able
this
to
is
see your screen, so you have to specify what you're looking at.
yeah. For example, in slot A, we have an array of, for example, here like this, uh, 10 and 15. Yeah.
Yeah.
Uh, this is the hour and this is the minute.
No, 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 no. So they are both hours. Like consider it to be hour. Um, like nine, nine to 10. Consider that.
Yeah. For example, the second value for slot A, we have array of this. Just this is not you know that showing that this is hour and this is minute.
I guess it's minutes. So you can just consider it as minutes, like because we are adding 8, right? So um, yeah, consider it as a minute.
Yeah, because we have the array of two like the 0 and 15.
Yeah. So yeah, that
Uh,
should be minutes throughout the day.
yeah, okay, let me. Uh, I think it's a very difficult question. I cannot solve it.
It's okay. It's okay.
Yeah.
I'll just give you a hint again. Uh,
Okay.
I have seen such questions, so I was able to do it. But yeah, like if
Okay.
you are
Okay.
seeing for the first time, it might be difficult. I totally understand that.
Yeah.
But yeah, like imagine you have two pointers. Okay,
Yeah.
consider two pointers. One is pointing at slot A, slot B. You know that
Yeah.
the time that has been given to us is in sorted format on the basis of the start time, right? So everything, if you
Yeah.
see the start time, 10, 60, 140 for person A. If you see
Yeah.
slot person B, 0, 60. So everything is increment, like the start time is sorted, right? You can see that. Is that right?
Yeah. Yeah.
So,
Yeah, yes, yes. Sorry, sorry. We have on slot A, for example, in array of one, first array, in first array, in you know, in for index 0, we have 10. For second array, for index 0, we have 60. For third array, we have 140. Yeah.
yeah,
How
yeah,
about the second value? How about the second value? This is for index one. Index one for all of three arrays. We have 50, 120, and 210.
yeah.
I do
So,
not understand
so
this.
they are ending time, like as I explained you, right? So,
Oh,
so
yeah, 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 yeah. Yeah, oh, I understand. Let me explain it. It's for example, in first array, it means from number 10 up to 50. This person in this array can be available. Yes.
yes,
And for secondary from index 0 is equal to 60, this person is equal to sorry, this person is available for from 60 to 120. It means 60 minutes, for example. If we consider it as a minute, uh, this person is 60, 120. It means is he have available time of 60 minutes on secondary, yeah.
Um, yeah, you can say that. Um,
This is the, for example, this is the start time. This is the start available time, and this is the ending time. Yes.
yeah, yeah,
Yeah. 60, for example, number 60, and from number 60 up to 120. It's he is or she is available for for example, if we consider it as a minute, 60 minutes in this slot, he is available. Yes.
yeah, yeah.
Okay, okay. And
But
for
yeah, go ahead. Sorry,
for
I didn't
example,
mean to interrupt.
yeah.
Hello. I guess there is a the network went out. Hello, are you there? Is it me or hello? Mm, what's going on here? Are you able to hear me? See you or hear you? I can't see you or hear you. I guess I'm not sure if he is coming back or oh, I missed my net connection. Okay, okay, okay. Yeah, he's there. Okay, got it. Um, I'm still not able to hear you. Um, are you able to hear me? Okay. Can you refresh your browser or tab? weird. Okay. Hello. Hey. Yeah, I can see you.
Sorry for my. I have lost my connection for a while.
No
Right now it's
worries.
okay.
No
Okay.
worries. Yeah.
Okay. Let me. Okay. Uh, I said in slot B we have an. For example, in first array we have 0 and 15. Okay.
Mm-hmm.
It means he is available for 50 minutes. Yeah, 10 and 60. Mm, can you give me a hint a bit? How should it start?
Yeah.
For example, we need. I think we need. Yeah, we need using object because we have a pure of value here. Yeah, or a hash table like.
I don't think so. We'll be needing an hash table here because we don't want to remember anything, right? We just want to keep uh, see if the slot is available, and if not, then
Hmm?
keep looking for the slot which is available. I guess we we are well into like 20 minutes, 20 or 30 minutes, I suppose, into the interview. So, what do you say?
Okay.
Like, should I give you the hint, or like straight away explain you the solution, or do you want to try more? And I'm not sure if I'm pushing you or like, but let me know if you what do you want? One more hint, or how is it like?
Well, sorry, because it's complex and complicated question. Right now, we should switch the rule because we spend more than half hour. We have 30 minutes remaining. It's we should switch the rule, and you should start. Okay,
Okay,
change the rule.
okay, got it,
I
got
should.
it.
Okay. Uh, yeah, I'm so sorry. I couldn't solve this challenge.
It's
For me,
okay.
it's very complicated. Yeah.
It's okay. It's totally fine. It happens to all of us. So yeah.
Okay. Okay. We should switch the role. Okay.
Okay, got it. Um,
Okay. Do you have my question
yes, I can see the
in your
question.
screen?
Yeah. Should I go through
Okay.
this question? What is it exactly? I'll read through it, and then probably we can start
Yeah.
solving it.
First of all, okay. You can read the question. Okay.
Yeah. Okay. I'll start reading the question. So it's a shortest cell path in a given grid of
Okay.
zeros and ones. Okay. We have some starting row and column SRSC and a target row and column TR and TC. Got it? Return the length of the shortest path from SRSC to
Okay.
TRTC that works along one value. One values. Okay, got it, got it. Each location in the path, including the start and the end, must be one. Okay. each subsequent location in the path must be 4 directionally adjacent to the previous location. Each subsequent location in the path must be 4 directionally adjacent to the previous location. Okay. So it is guaranteed that grid SRSC is equal to, okay, got it. And the starting and target positions are different. If the task is impossible, then return -1. Got it. So looks like we have a grid here. Let me, and I'll explain you what I understand. Oh, sorry. Did my camera turned off, or are you not able to see my? Okay. Hello. 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 Hey. Let me refresh. I refreshed it. I guess he might be also refreshing it. I missed my Wi-Fi connection. I'm using mobile hotspot. Okay, I guess he might be using mobile hotspot. Data bundle, please off you. Okay, got it. How can I turn it off? Okay, I guess, yeah. Hello. So, I guess because of the technical difficulty, like I guess he doesn't have a data connection Wi-Fi. Hello. Hello, are you there?
Yes, yes, yeah, I can hear you right now.
Okay, got it.
Please off.
I turned it off. Hello. guess my peer is offline. Uh, I'm sorry, my net connection is not good. Okay, it's okay. It's totally fine. Yeah, we can. Are you here by any chance? Are you able to hear me? If the connection is really bad, then we can end the session. Else continue. What do you see? Okay, I guess I'll just end the session. It's okay, guys. Will or should I continue this and just explain it in in to you guys? Okay. So what the question is saying that there is grid given to us. Okay, and that grid um, is having 1 1 1 ones and 0 0 0s and 1. Okay, so we have been given the start time and the start of source and the target um, indexes from where we have to start and where we have to go. um, I can open the Miro board and hopefully I can draw the what do you call it, I can draw the 2D grid that has been given, matrix that has been given to us, and hopefully we can uh, track what is going on and go about the solution. So we have, okay, let's try to do it here. Like if we have an interview where that is not allowed, so we can just use this. We have given 1 1 1. Okay, the next one is 0 0 0 and 1. Next one is what is the next one? 1 1 1 and 1. So this is 0 1 2 and 3, right? Yeah, and this is 0 1 and 2. The indexing, I have done the indexing. Our sources are no worries, I'm okay. So we the source that is given to us is 0 0 0 and 0 and s, and the target that has been given to us is 2 0. So looks like we have to reach here and from here. Okay, 0 0 is our index and 2 0 we have to reach at. So that's that. Each location in the path, including the start and the end, must be 1. So we consider this once as the road. So we have to follow this road and reach to the 2 location in the path must be 4 directionally adjacent to the previous location. Got it. So yeah, what we can do is we have to make sure that we can travel in 4 directions, 1 2, like top, bottom, and right left. So that's how we can travel. So let's say we travel from here. I'm thinking of using DFS for this problem, but yeah, if you go from 1, you cannot go to the top or bottom, because bottom is 0. Then I'll go to 1. The next I can go to left, go to right, and then similarly I can keep on going on right, but I have to make sure that I don't revisit the road that I visited. So for that I can just change the value to 0. Can I do that? Yeah, I can do that, and then probably change the value back so that I don't take the revisited road again, and then later on make it 1 again. So yeah, I can do that, and possibly reach to reach to 2 following the 1's path. And okay, so we have to take the minimum shortest cell path, right? Shortest cell path. So minimum value should be taken in this case. So I'm thinking, how should I be doing that, keeping track of that? So I can keep a variable where I can store the value. Okay, and if it is not reachable, then I have to send -1, right? Okay. Let's get rid of the messages, and yeah, this looks good. So possibly I want to check if there is any edge case that I'm missing. The lines below represents this grid 1 1 1 1. Okay, so array of 10 rows can be 10. Source will be not equal to target, that is for sure. Okay, output is integer always. Got it. So what I'll do is I'll have let minimum path is equal to, I'll use a number dot max safe integer. Okay, so I'll have this, and while returning, if minimum path is equal to, and let's call it inf, let inf is equal to number. Let's copy this so that we don't have to type this over and over again. Inf, if number is infinity, then we return -1 or else min path. Okay, so that is my idea behind this. I'll have what we need to do is we have our source, so we don't have to traverse everything and each and everything. So we can simply go to this. We have our source, we have our target, DC, which is, and we have our, yeah, so we just need these, or in fact if we don't even have this, then it is fine. But yeah, I guess I won't need the the table row and table column, like, sorry, the target row and column. So yeah, let's do DFS. I was thinking of doing DFS. So we'll keep on exploring all the paths where one is there. Okay. Okay, so what I need to do is, if my minimum, if my, I need to send source, right? So R and C, let's call it R and C. If my R is less than 0, that means I have reached the boundary. I cannot go further. Or R is greater than. One more thing I should have done is that I should have calculated the row length, which is grid dot length. Okay, and let column length is equal to grid of 0 dot length. Okay, so row length, if it goes greater than row length -1, that means the last element, then we have to not proceed further. And this is the edge case for column length -1. So yeah, once we reach here, we cannot go any further than this, so we return so we return 0 in this case. And one more thing, if R is if grid of R and C is equal to 0, then also, and yeah, then we'll return 0 in that case. Okay, if grid of T, TR and TC, sorry, if R is equal to, sorry, if we reach, if R equal to TR and C is equal to TC, that means we have reached the end of the target, like our target destination, and that point of time we can return 1. Yeah, we can return 1 at that point of time. And okay, so now we have to go traverse. So for us, not not to visit the same road again or the node again, we have to make it to 0. We'll make it to 0, and what we'll do is we'll traverse top, bottom, sorry, um, top, let's go clockwise, top, right, bottom, left. Okay, we'll traverse in this way, and what we'll do is DFS, right? R, DFS, R plus 1, sorry, minus 1 is top, and then C as is, then DFS R plus 1, C as is, sorry, it will go to the bottom, C plus 1 would be the right, and DFS R plus 1 should be bottom, so row will be incrementing the row count, so it will go to the bottom, and left would be R as is, and C minus 1 should be our left. So yeah, we'll get them in whatever the value will come, we'll take them in top left, sorry, right, it's a right, yeah, and then let bottom equals to this, and let left is equal to this. So what we need to do is we need to add all of top, right, bottom, left, because we'll get or else what we can do, I'm thinking, sorry, I'm thinking that we should probably take the count and go ahead instead of coming back. I think we should do that. Yeah, I think I'll do that. So instead of returning 1, if I come here, so whatever count that I've accumulated so far, the minimum path, so I'll just see minimum path is equal to math dot min of minimum path, whatever the minimum is there. I guess I also need to maintain path so far that I've taken. So do we count inclusive? So 1 2 3 4 5 6 7 8, so it's not inclusive of the last path that we take. So 0, let's say 0, source will start at 0, and whatever we do, we go path plus 1, path plus 1, path plus 1, and path plus 1, and so whichever will go to the end, then we can simply store the path, and then we can make our grid R and C equal to 1, whichever we have done so far recursively. I guess this should work. So path, yeah, this should definitely work. If I'm missing any edge cases, I should I guess I can just move this guy here. Yeah, so if I'm not missing any edge cases, then this should be good, because at the end I'll be left with this. Yeah, that should be good. Okay, and I don't even have to return anything at this point of time. Just I can just return, and I don't even have to store the value in anywhere. I can just call these guys, and I can straight away go. Hopefully this is good, and then we can simply return min path. Okay, let's give it a try. I'll just delete everything here and then just get this these values. Let grid is equal to this, and let source is equal to this and this, and let's pass this thing to, let's call this console log shortest path is dollar and let's pass what values are grid, then grid sr sc tr tc to it, and we can, okay, hopefully I've done it right. Okay, yeah, we got 8. We got shortest path to be 8, so this works. And let's do it for this as well. So this time around I'll comment this out, and this time around we should be getting -1 because nothing can reach to the end. And yeah, so we got -1. That's good. So our 2 test cases have passed so far, and let's run the test cases. In real interview, you won't always have this option. To help you prepare, we recommend that you evaluate your code only after you feel that your solution is complete and correct. Are you sure? Yes, I'm ready. I have evaluated it. Okay, yeah, everything passed. So this looks good. And let me share the time complexity of this. So at worst case, we are going from 0 0, right? Like from wherever the source is. So at worst case, we will be traversing all the routes, all the possible routes. I guess it would be for every position we can either take if everything is 1, consider everything is 1, then mn to n we might be taking decisions. So for every node mn to n we can take 4 decisions. Does it mean that 4 raised to mn to n is that the time complexity for this? And the space complexity would be mn to n itself. Thank you so much. I can Okay, so I can share my LinkedIn. So it's in my sticky notes. Hopefully it doesn't show up here. So it does. Where is my LinkedIn? Yeah, I have my LinkedIn here. Okay. Uh, uh, yeah. So let's end in this call, and hopefully that was hopefully Okay, guys, we'll end the session. Hopefully, this was helpful. Bye bye.